so today is a continuation of plotting data, and I like to thoroughly cover the box and whisker plot and the stem and leaf plot, and that's why I break these up into 2 days. But it's one lesson in your book. Okay, so 10B is our stem and leaf plot. So a stem and leaf plots. Why would you use a stem and leaf plot? Well, these are used to display the data within its intervals. Intervals. These are used to display the data within its intervals. The best way to explain it would be to use people. All right, we've got an election getting ready to happen, right? And there's all kinds of primaries going on right now to figure out who the Republican candidate for president will be, who the Democratic candidate for president will be. And there's all kinds of polls, and numbers of the polls break the data down into demographics. And demographics is different items of the data. For example, poor, wealthy, middle class. There's all kinds of different demographics. But one demographic is by age. Now, most polls don't care about 0 to 9-year-olds. And most polls don't really care too much about 10 to 19-year-olds, although a little bit, because you can vote at 18 in this country. But it's interesting to know 20 to 29-year-olds, that's an interval. 30 to 39-year-olds, that's an interval. 40 to 49-year-olds, that's an interval. 50 to 59-year-olds, that's an interval. 60 to 69-year-olds, that's an interval. 70 to 79-year-olds, it's an interval. And so you form your data, and it readily helps you to understand what's happening in an interval. Most of the time, the intervals are just like that, sets of 10. We could do this with a test. You could look at the data in an interval and see, all right, who got a score from 60 to 69? How many people were there? How many were between 70 and 79? That interval. How many were between 80 and 89? That interval. How many were between 90 and 99? That interval. How many were between 100 and 103? That interval. Okay? So intervals. That's the idea of a stem and leaf plot. Now, not every stem and leaf plot is created equal. There are a couple different ways they can look. They don't always have a title. Though if you ever make one, you should always have a title. But unfortunately, not every time will you see a title. This one is California temperatures. They rarely will use the word stem. I have it there so you understand that the left-hand side are the stems. Rarely will they have the word leaf, but again, I have it there so you understand that the right-hand side are the leaves. Talk about them again in a moment. And then there's not always a legend. Okay? A legend. You guys know what a legend is, right? All right. That would be like, like me when you're talking about. No. All right. A legend tells you what the data represents or how to figure out the data. So there's not always a legend included in a stem and leaf plot. It's good to include a legend because sometimes you're unsure of what exactly the data represents, and the legend helps make the data more clear. Same with the title. That's why you should always have a title, because the title helps make the data more clear. The idea of any visual, which is what a graph is you want somebody to be able to look at your data without anybody explaining anything and then know what's going on. Whenever you make a bar graph, that should be the case. Broken line graph, a box and whisker plot, a stem and leaf plot, etc. Should include things like the title, like a legend, to help an individual looking at your chart to figure out what in the world it represents and what the data is. Okay, so here is what's going on here. The stems are The first stem is a 70. The second is an 80. The third is a 90. And the fourth is a 100. Because if you look at the legend, if you have 7 on the left-hand side of the line, a stem, and 2 on the right-hand side, a leaf, it gives you the value of 72. See, what this does is tells you how many pieces of data do I have in the 70s. I have 1, 2, 3, 4 pieces of data in the 70s. How many pieces of data do I have in the 80s? I have 3 pieces of data in the 80s. How many pieces of data do I have in the 90s? I have 5 pieces of data in the 90s. And how many do I have in the hundreds? I have 1 piece of data in the hundreds. So that's the idea of a stem and leaf. If we were to list all the data, and I want to do this, and so take your pen, I don't care what color you're doing it in, but off to the left, let's list the data so you clearly understand. So there's a 72, comma, a 75, a 77, a 79, an 82, an 83. You follow what I'm doing, right? You can look at your own and do it. An 86, a 92, a 93, a 95, a 98, another 98, and finally 102. Right? That's the actual data. But the stem and leaf displays the data in its intervals. So we clearly see the intervals, how many in a certain interval. The mode is usually pretty easily seen in a stem and leaf plot as well. What would be the, somebody raise your hand and tell me what would be the mode of this data? What's the mode of the data? Nia?
2.
No. Nope, there are no 2s. There's no 2 data. Brendan?
98.
98 is the mode. See that top 2, it's a 72. This is an 82. This is a 92. And this is a 102, right? So you have to understand the data is, you have to put the stem with the leaf to really understand what the data is. But there are 2 98s, right? And there's not 2 of any other piece of data. So the mode is 98. All right, so again, the leaf is always the last digit of the data. These can be decimals. That's possible. Now, when you're making a stem and leaf plot, you got to make sure the leaves line up in vertical columns. You sloppy people, you're going to lose points on your stem and leaf plot because you don't line things up. It's important that the leaves are lined up because, listen to me now, what is the main purpose of a stem and leaf plot? To determine how many pieces of data are in each interval. If you don't do it in columns, it'll be hard to determine. You have to go in and count everything. And the idea is not to have to count. I can readily see that the most data is in the 90s and the least data is in the hundreds. I clearly see that because everything's lined up, and therefore the leaves that go the furthest has the most in it because everything's lined up. But if you didn't line it up, you wouldn't be able to tell. So again, don't write this. This is what some of you will do. 3, 5, 8, 8, and up here you go 2, 3, 6, and over here 2, 5, 7, 9, and now you can't tell anything. You follow? You got to keep things in vertical columns in your leaves because remember the value of the stem and leaf is to readily see the intervals. All right, B. The stems, again, all data digits except the last digit. I mean, your number could be in the thousands, right? It could be in the hundreds of thousands, etc. Okay, let's do some statistical analysis of the data. Let's find the mean. So we've already listed the data, so let's just take an arrow and we'll just point up to where we've already listed it, right? We already have all the data listed out. So for time's sake, to do the mean, would you agree we'd add up all that data? Now look, To do the mean, don't be adding 7 plus 8 plus 9 plus 10. Don't be adding 2 plus 2 plus 2 plus 2. Right? You got to add 72 plus 75 plus 77 plus 79. And for time's sake, when you do that, you get 1,132. Now, how many pieces of data? If I count the leaves, I'll tell you how many pieces of data. 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 13 pieces of data. So you're going to take 1,132 and divide it by 13. And how should you finish your answer? In what kind of form? All right, 1 decimal place is how we usually round. So somebody do that on your calculator. Raise your hand. Colby?
87.1.
It is 87.1 is the mean for that. All right, we already said the mode was 98, right? Okay, how about the median? What piece of data, if there are 13 pieces of data, which one is the median? Luke?
86.
Well, which out of 13 pieces, which numbered piece? There's 13. Allison? The 7th, right? So 1, 2, 3, 4, 5, 6, 7. And you could count the other way, right? 1, 2, 3, 4, 5, 6, 7. No matter which way you go, the middle piece of data is 86, as Luke said, right? So the median is 86. And somebody tell me the range of this data. Brendan?
30.
It is 30. Brendan took the high, 102, and subtract from it the low, 72. 102 minus 72 is indeed 30. Okay? All right, so here is 8th graders IQ. Maybe you're on this chart. All right, there's no legend. It doesn't say stem and leaf, but we know it's a stem and leaf plot by its look. So, can you figure out the mode, the median, and the range? All right, I'm going to pause the video. You guys should do that. Figure out the mode. Okay, so on 3, give me your mode. Here we go. 1, 2, 3.
96.
It is a 96. On 3, give me your median. 1, 2, 3.
96.
It is not 96. On 3, give me your range. 1, 2, 3.
51.
51 is the range. I'm goofy on my letters, aren't I? That's what always happens when I cut and paste. 51 is the range. The median should be 95. There are 14 pieces of data. Therefore, you have to average the middle 2, which is the 7th and the 8th. Now, be careful the way you count in. The lowest is the 8, the 78, then the 79, then the 85, the 86, the 87, the 92, the 94 is the 7th, and the 96 is the 8th. And those average to a 95. 14 pieces of data. Now again, if you can't figure that out that way, list out your data. But you don't want to miss the problem. It's too easy. Any questions on the median? Edward?
For the 11 one, is it 11 or is it?
There are nothing in the 110s, right? This would be like 110, 111, 112, 113. There is no data. But notice the 11 is there. You don't want to have a stem that's a 7, an 8, a 9, a 10, and skip right to a 12. You want to include that interval so the person looking at your stem and leaf understands there are no intervals in the 11s, the 110s. So even though there are no data there, we want to include that stem because remember, we're given a visual of the intervals of the data. Okay? Any other questions on that one? Any other questions? Okay. Now, if you make a stem and leaf plot tonight, you should use graph paper. Okay. So I gave you one. So number 4, go ahead and make a stem and leaf plot concerning that data. The key here will be your legend. Key is another way of saying the legend. And here, let's do that part together. Watch, this is how this will go. Let's use a 4 the bar for the line between the stem and the leaf, and then let's put 5. Anybody see any decimal points anywhere? There aren't. However, when I say it equals, what am I going to write it equals? 4.5. Okay? So now see if you can make a stem and leaf plot. How many have a title? Ah, you must have been paying attention a minute ago when I talked about titles. Oh, for me, you'll always have a title for every graph you make. And if you don't, you're going to lose major points. Because again, you need somebody to be able to look at your graph and understand what's going on by looking at your graph. So you always want a title. You want your title to be as descriptive as possible. In this case, I don't know that you could leave out any words because every word is important. NFL Combine 40-yard dash times. Every word's important. Now the stem should have been 4 and 5. That's pretty much a no-brainer. And again, the leaves, you just do the leaves are always in order for that interval. So the first one was a 4.2, so the 2 had to come first, then the 3, the 3, the 4, the 4, the 5, 5. I missed a 5, didn't I? Missed a 5. How did I miss a 5? All right, a 5, 5, 5, then the 7, 7. And then for the 50s interval, we had a 5.0, a 5.1, and a 5.3. Clearly, most of the times were in the 4-point, right, times, and there were a few in the 5.0s, probably some linemen. Right. Questions on that? Anybody? Aaron? You do not. Your key takes care of the fact that it's a decimal. You do not include the decimals in your actual stem and leaf plot. The key takes care of it. Any other questions on that one? All right, B are scatter plots. Scatter plots. And I've got 3 of them here for you. So the first one is ice cream sales. The amount of sales is on the left, and the temperature in degrees Fahrenheit is at the bottom, right? What does the data tell you? Somebody raise your hand and tell me what the data means to you. Brendan?
They have more sales when it's warmer than when it's colder.
Yeah, the warmer it gets, the more ice cream you sell. That's logical, isn't it? And that is true. And again, it just shows the data in that way. In the second situation, it's temperature and burger sales. And as the temperature increased, what happened to our burger sales? They went down. You know why? Because more people are buying ice cream and stuff. That's why. Now, coffee, everybody loves their coffee. And it doesn't matter if it's hot or cold, they're drinking their coffee. So it's kind of all scattered all over the place. A scatter plot could be that way. It could be in a lot of different places. There's a lot of different possibilities. You guys don't have this in your notes, but this is in your book. And this is the data. This is a scatter plot. And it's used to represent 18 people whose height is given in inches. So height is in inches, it tells us. And you can see that that's right there, right? That the x-axis of the scale is height in inches. And it says whose weight is given in pounds, and that's this side of the scale, weight in pounds. And the correlation is, as you increase in inches, you increase in pounds. Now with a scatter plot, you don't get a nice straight line, but often you can draw a line to represent the data if the correlation, listen now, is strong enough. If the correlation is strong enough. Back here, the first 2, the correlation was strong. And you could come up with a line to represent the data. In the second one, the correlation was strong. And again, you can come up with a line to represent the data. In the third one, the correlation is very weak, and who knows where you'd stick a line. There's no good correlation. In this example, the correlation is not extremely strong, but there is a correlation. So when it's a strong correlation, it's when as the bottom increases and the left scale increases. In other words, if basically the data is moving up to the right, then that's called a positive correlation. So you can see which one here had the positive correlation. The ice cream. And the hamburger would be what kind of correlation? A negative correlation. As you increase the temperature, what happens to the output? It decreases. It's a negative correlation. So this one here, as you increase height, you increase weight. That's a positive correlation. They go together. As you increase the one, the other increases. Negative correlation, as you increase one, the other decreases. There's one other one I just had to get to. This is in your book, and this one's apropos. They should also do it with video games, which is why today in our society in America, most girls easily, hands down, outscore the guys. Because most of the guys are wasting their time on their video games. But there is a correlation between hours a week you watch TV or whatever other media device now you want to stick in there, and your GPA, your grade point average, how well you do in school. And what happens as you increase the hours watching TV? What happens to your GPA? It goes down. Well, of course, it's going to go down. Now, it used to be that's all you had to fight was the TV. Now you got to fight the video games as well. And people that can't get away from their video games, and their parents, for some reason, don't limit their video games. And here's what happens today as well. Some parents have this rule. I hope parents are listening right now. Okay, get your homework done and then you can play your video games. Somebody raise your hand and tell me the danger of that. Go ahead and get your video game done or your homework done, then you can do your video game. Hannah? You will rush through your homework to get to your video game. True? Oh, that is true. Oh, that is true. Gee, Mom, I have no time for homework. I played blank video game for 3 hours last night, but I have no time for my homework. Direct correlation. Direct correlation. And by the way, TV, the body loves watching TV. You know why? Because it's just doing nothing. And our bodies like to do nothing. But you're not becoming a better person by doing nothing. And believe me, the TV is not helping you. So shut the TV off. Close out the video game and do some studying and make yourself a better person, and that would be good for you. But that is a direct correlation. All right, we'll stop there.